Welcome back, everyone. In this lecture, we're going to focus on how to actually read in data with PyTorch, particularly how to use PyTorch's built-in dataset utility functions. In part 2, we'll talk about accessing the built-in datasets provided by the Torch Vision library, which we'll be using during the convolutional neural network portion of this course. But right now, for part 1, we're going to focus in on loading data from files. Keep in mind, I'm going to be copying and pasting some visualization code from the Datasets with PyTorch notebook that corresponds with this video lecture. All right, let's get started. To start off, I've gone ahead and imported Torch, NumPy as NP, Pandas as PD, and then since we'll be copying some visualization code, I've imported matplotlib.pyplot as PLT. And depending on what version of Jupyter Notebook you're using, you may need to call matplotlib inline if you're using a notebook in order to see the visualization take place in this notebook. Let's go ahead and just quickly check how we can load in data from files. So we've actually already seen during the crash course that we can actually load in CSV files with pandas. So I could say df.pd read CSV, and underneath the folder, the data folder that we provide for you, there is a file called iris.csv. Keep in mind, depending on where your notebook is located, and you can always use pwd to locate that, you may need to provide a full file path. Or if you're located deeper in a notebook, you may need to say ... to go back up a directory, or just ... /. Again, please review read CSV and how to read in a file in case you get an error when running this line. Or just run our lecture notebook directly from its original location. So that's reading in that iris CSV file. We check the head, and this is a data file that contains various features on the iris flower along with a target. So essentially, the iris flower can have a sepal length, sepal width in centimeters, as well as a petal length and petal width. And there's 3 species of flowers. There's Iris setosa, Iris virginica, and Iris versicolor. And then the target label is going to be either 0, 1, or 2, depending on that. So you're probably already familiar if you've done any machine learning course or even just read on machine learning online with this iris CSV file. If you're not, you can also check out the iris dataset Wikipedia page by simply Google searching iris dataset plus Wikipedia. If we take a look at the shape of this, so df.shape, we have 150 rows by 5 columns, the 4 features and the 1 target label. Let's go ahead and plot out this data. In order to plot this out, there's a little bit of complicated code that I'm just going to copy and paste from the notebook. Don't worry about understanding this code. This is really just so we can view a nice visualization. And what we have here are the 3 colors, or 3 classes, Iris setosa, Iris virginica, and Iris versicolor. So those are the 3 labels, 0, 1, and 2. And then we've plotted them out against various features. Basically, what this shows you is that the Iris setosa class of flower, the ones in blue here, are very distinct from Iris virginica and Iris versicolor, especially on features regarding their petals. So we can see here petal width versus petal length. Iris setosa tends to have much shorter petals and much or less wider petals than virginica and versicolor. And we can see here on also other features, such as petal width and petal length, that virginica and versicolor tend to be separated as well. But when you look at the sepals, virginica and versicolor tend to have a little bit of noisy overlap. So we have those 3 classes, and let's go ahead and show you a classic method for building train test split tensors if you're already familiar with scikit-learn. So if you're familiar with scikit-learn, you could use the scikit-learn's train test split to actually do the train test split and then convert those into tensors. Let me show you what that would look like. And we're going to show you 2 approaches. One is this more classic method, and then the other one will be PyTorch's dataset and data loader classes. But I want to show you both since depending on the situation, you may find one more convenient than the other. But you'll say from sklearn.model_selection import train test split. And now the next step will be separate the features. So recall that the features are sepal length, width, petal width from the label, which is target. So we have these X features and we have this Y label or Y target. And we want to separate out those 2 for the train test split, which makes sense. We want to separate X from Y's. So how do we do this? Well, we can do this in all one long line step, and that's done in the lecture notebook, but for this video, I'll do it in a couple of steps. For the features, that's simply going to be df drop, and I'm going to drop the target column. Since it's a column, I need to recall that I should be specifying axis is equal to 1, and I don't want this as a data frame, I just want the actual NumPy values, so I can call dot values off of that. Then for the label, so for my Y label, that's going to be equal to df and only grabbing the target column. And later on, since we're going to be converting these to PyTorch tensors at the end, we'll just grab the values off of that. So there's my features, there's my label, essentially X features, Y label, and then you just call train test split, do shift tab here, and if you ever worked with scikit-learn, this should feel very familiar to you. We can scroll down here and then end up grabbing X train, X test, Y train, Y test. Go ahead and copy that to save yourself a little bit of typing time, and then we'll pass in the parameters to this function. The first one being the features, next one being the label, and then we also want to specify what percentage of the data should go to the test set. We'll say 0.2, signifying that we want 20%. And then finally, to make sure you get the same random split that I do, since this will be shuffled internally, we'll say random state is 33. 33 is an arbitrary number choice, but make sure you provide 33, that way you get the same split I do if you're following along. Or you can just run our lecture notebook directly. Okay, so if you run this, now you have xtrain, and notice that right now it's a NumPy array. What we want to do is convert these arrays into tensors by casting them into tensors. So how do we do that? Well, we simply say xtrain is now equal to, and then using torch, you can call float tensor, and then pass that in for your training features. So we'll do the same for xtest. So say torch, float tensor, and then pass in xtest. And the features themselves, those should be floats because we want to actually have that float data, so like 5.1, 4.9, etc. The target itself doesn't actually need to be a float because 0.0 is actually just class 0, and then later on 1.0 is just class 1 and class 2. So what we can do for those guys is we can just cast them as long tensors instead of float tensors. So we'll say ytrain is equal to torch dot, and we'll say long tensor, and then we'll pass in ytrain. And then what we're going to do here is we will reshape this as -1 by 1 so that we actually get it as a column instead of just a long vector. So to show you what I mean by that, if we were to actually take a look at what ytest or ytrain currently looks like, I'm going to comment this out so I can get a new cell here. Look at ytest. Right now it's just a one long vector. I actually want it to be a column so it matches up with what xtrain and xtest look like, which is why I'm calling that reshape -1, 1. Okay, so let me uncomment this. So that's ytrain, and I'm going to copy the exact same command for the y labels for my test set. Let's go ahead and grab that. There's my test set. Grab that. There's my test set as well. We'll go ahead and run that, and now we have xtrain, xtest, ytrain, and ytest. Be careful not to run these multiple times, otherwise you're kind of casting a tensor back into a tensor, which doesn't really make sense. Okay, so I have my xtrain, xtest, and let's just take a quick look at one of them so we can confirm that now it's a tensor, and note here, now it's correctly formatted to match up with the columns that the xtrain, xtest have. So now it has one long column, and it's going to match up with the rows there. So that's one way you can perform the actual conversion of this tabular data, a CSV file. You can see here we loaded it as a pandas data frame, and then we did our classic scikit-learn train test split and just manually cast it to tensors. So that's method 1, which is a little more manual, but it works just fine. Let's go ahead and see how we can use PyTorch's built-in utilities. And PyTorch has a utility, or really just a class, called DataSet and Data Loader. Let me show you how you can grab those. We'll say from torch.utils.data import, and we're going to import tensor dataset, note the capitalization there, and then data loader. And let's go ahead and redo this again. If we take a look at our original data frame, we haven't actually changed anything on that original data frame. So we're going to pretend that we just read in this data with pandas. Then what we're going to do is we'll say data is equal to, we can also call this features, df drop target along axis equal to 1 because it's a column, and I just want those values. And then we'll say labels is equal to df target, and I just want those values. So this is the exact same thing we did last time so far, except now for the train test split, we're going to be using this tensor dataset utility. So how do we actually do this? Well, I will say my iris data, or whatever variable you want to call it, call tensor dataset, and then you're just going to pass in, and you're going to say torch float tensor, pass in the data, and then the corresponding label. So this kind of feels like PyTorch's own train test split utility because we're already having to separate the features from the corresponding label. And then we'll call this long tensor because we just want these to be integers, and we'll say the labels. Okay, so there's iris, and if we check out the type that iris is now, it's the specialized PyTorch tensor dataset object. So let's actually show you what you can do with iris. If you check the length of iris, it currently contains all the samples, 150 rows, and we say for I in iris, go ahead and print I. You could also say row. You can see now it essentially contains both the features as their own specialized tensor and then the label as its own tensor. Note that this is now an integer because we specified long tensor. So far this is pretty good. We can actually iterate through this object, which is nice. But what's important is we're actually going to have to be able to shuffle this object. So we can use the data loader for that. And essentially the idea is that once you have your data essentially converted to this tensor dataset object, you can wrap it with a data loader, which is this very convenient loader object that we'll be using, especially for large neural networks that can shuffle the data and actually produce batches of the data. That's why this data set is so important, because when you're working with a neural network, you don't want to feed in all the data at once, especially if you're working with a huge data set such as 100,000 samples. You don't want to feed in 100,000 samples at once. Instead, you'll grab little random batches from the data and then feed those in until you've gone through all the training data one time, and then that's one epoch. So that's where the term batch comes in. And if you start doing it the manual way with this train test split, you'd have to figure out your own functionalities for actually splitting things up into batches and then feeding those in if you have a large enough data set where that's necessary. If you have a really large data set and you use this tensor dataset and data loader functionality, the data loader is going to be able to shuffle and produce those batches for you, which is really going to be necessary when we're dealing with really large data sets, which we'll do later on in this section of the course. So let's go ahead and make our iris loader variable or object. And we'll say data loader, and then we pass in iris, which was that tensor dataset object. And then here I get to describe a batch size that I'm interested in. So I can say my batch size is equal to maybe, let's say 50 points or 50 rows at a time. And then I can say shuffle equal to true. So I want these to be shuffled. And now I have this loader object. And if you take a look at the loader object, you can say for I underscore batch, and then sample batch in, and we'll say enumerate iris loader. Let's go ahead and print out iBatch, and then along with it, we'll print out that sample batch. So what is this actually doing? This is essentially reporting, okay, here's your first batch indexed at 0, and then when you shuffled it internally, here are your first 50 points that go along with that batch. And then here are those corresponding labels. Then we have batch number 2 or 1. And then here's those 50 points, etc. And then here are the corresponding labels. And then the third batch, which we index at 2, there's the last 50. So hopefully it makes sense to you intuitively why we have 3 batches, because we asked for each batch size to contain 50. And 150 divided by 50 is equal to 3. So that's a total of 3 batches. If we were to redefine this by, let's say, 10, so 10 rows per batch, then you should see 15 batches total. So let's go ahead and redefine that, rerun this, and now as you keep going, you'll see the much smaller batches that only contain 10, and then as you go along, you see it ends at 14 because it starts at 0. So hopefully this gives you the intuition of how to actually use data loader in order to feed in batches. And you don't need to enumerate it if you don't want to, because this iBatch is essentially just showing you the number of the batch. Typically, what you would do is just say for batch in, and then you would see something like iris loader, print out that batch. So that's how we're typically going to be running through a data loader, is just going through it. And if we don't really care about keeping track of what batch we're on, we can just iterate through this iris loader object or this data loader object, and it will spit out the batches as you prescribed. And in this case, we're asking to shuffle the data before spitting out that batch, which makes sense because we want to actually use this for training data. Okay, so for right now, that's all the basics that we need to actually know about for dataset and data loader. And we'll be seeing this data when we actually perform a very simple and basic PyTorch neural network. So for the first basic PyTorch and neural network, we'll be showing you a bit of both with running data loader and also using train test split to split it up into a test set and training set. We're going to take a slightly different methodology when we reach a really large artificial neural network, so keep that in mind. We'll kind of show you and ease you into it as far as the train test split and using tensor dataset and data loader. Coming up in part 2 of this lecture series, we're going to go over how to use the Torch Vision datasets that we'll use not in this section of the course, but later on in the convolutional neural network. So if you really want, you can actually skip the next lecture and then come back to it once you hit that CNN material. Okay, thanks, and I'll see you at the next lecture.